All right, so in today's episode, we're going to do some more talking about genetics and some slightly more complex types of inheritance. And one of those complex types of inheritance is blood type. Blood type is not as straightforward as you might think. There are different blood types. You've got A, B, AB, and O. And what ends up happening is with blood type, you have a combination of dominance going on. So blood types A and B are co-dominant, which is how you get that AB blood type is you have an A and a B allele, but O is recessive to both A and B. So how this looks when we set up a Punnett square is a little bit different. So because the A, B, they are what we call blood factors, we don't just use the A's and the B's. We use an I with a superscript letter. So what this is going to look like is I with an A, I with an A. Now, that is not the only way to be an A blood type, but I'll come back to that in a second. If you're blood type B, IB, IB. If you're AB, you'll have one copy of each. And then if you have type O, you actually have no factors. You have neither A nor B, so you are just an O. So you have little I. How cute, right? Little eyes. Two little eyes. Now, because these little eyes are recessive, if you are blood type A, you could also potentially be IA, little I. So this would be heterozygous for type A. If you're type B, you could also be IB, little I. And that would also be the heterozygous genotype for type B blood. If you're AB, there's only one way to have AB blood, and that's one copy of each, an A factor and a B factor. And there's only one way to have type O blood, and that's two little i's, two of those recessive alleles. So let's take a look at how we would do some Punnett squares. So a woman who has type O blood and a man who has type AB blood want to have children. What are the chances that their child will have type A blood? Well, let's try it out. All right, so type O is that little I, and AB is that IAIB. All right, little I, IA, IB. We use that same crossing over and down, the same shuffling we do with any Punnett square. IA, little I, IA, little I, oops, IB, little I, IB, little I. So, chances their child will have type A blood. These would be type A blood, and these would be type B. So it's a 50% chance that their child would be a type A blood. Let's try another one. A woman who is homozygous for type A blood and a man who is heterozygous for type B blood want to have children. What are the chances their child will have type B blood? Notice what I've put in here. This is key when you're doing these. Homozygous for type A. You need this piece of information in order to actually get an answer, because there are two ways to have type A blood. But we do know, so this person is homozygous for type A. So big A, IA, and then heterozygous means they will be IB, and then little I, right? So that's the recessive allele that pops in, makes it heterozygous. Let's do that cross. Let's check it out. IA, IB, IA, IB, IA, little IA, little I. So these two here, these would be type AB, and these would both be type A. They happen to be heterozygous. Notice they've got that O, recessive O allele in there that gets covered by that dominant A. So these are heterozygous for type A blood. So what's the chances their child will have type B blood? 0. They will either have type AB or type A. All right, so check out the next video on sex-linked traits, and then you can try out some practice problems.